Hi everyone, welcome back to the lecture 13 in the series of Business Analytics course. In this video, I am going to do PYQs for week 6. And without a further ado, let's just get started. So this is one question from your PYQ. So let's just read this question. What does this question say? The question starts with data on urban population of a country and the GDP of the same country are collected in the is captured. The GDP is captured as percentage, that is 10.5% is captured as 10.5, and the urban population is captured as crores of people. That means this is captured as 1.2. From the raw data, the analyst has identified the relationship is non-linear. Hence, the analyst applied natural logarithmic transformation on both the variables, independent variable GDP and the dependent variable urban population. The transformed model of the data is modeled using simple linear regression, and the developed model is presented as this thing. Using this information, answer the following sub question. So now you see this thing. They are saying we have access to GDP and we have also access to urban population. So maybe I can give you this highlight. Your original data would look like something like this. I have urban population and then I have GDP. Okay. But this relationship was not linear. So therefore, we applied, ln urban population, ln GDP. So this is what we have. Now, these two are linear. So now we can apply linear regression on this. And if you remember this thing, this is very similar to your constant demand elasticity curve, right? Um, where we had a non-linear relationship between demand and price. So we were not able to apply our linear regression model, and hence we went ahead and we did log-log transformation, and then we were having a linear model. So then we can apply linear regression. So you can read this thing, and this is what they're saying. See this thing. From the raw data, the analyst has identified that the relationship is non-linear. Hence, the analyst applies natural log transformation on both variables and independent and dependent. The transformed data model is used, modeled as simple linear regression, and this is the output which you see. Okay. Now see this thing. How many degree of freedom will be present in regression term of the ANOVA table, right? So if I would be making the ANOVA table, then how many degree of freedoms would be there? So if you remember, as I said, the degree of freedom for regression in the table, I explained this thing here, that degree of freedom for regression is nothing but my number of predictors which I'm using, number of independent variables. So therefore, because here I am only using one variable, GDP, or you can say, to be precise, we are using log of GDP. Therefore, it must be 1, right? We are using ln GDP. Therefore, only one variable is used, and hence the degree of freedom for this is going to be 1 degree of freedom for regression, right? So how many degree of freedom will be present for the regression term? It is going to be 1 because we are only using, GDP. Then the question says, if the GDP was in 2024 was 15%, then what is the predicted UP, or you can say urban population, based on the SLR model? Okay, so remember this thing very specifically. This SLR model is for log of UP and log of GDP. Okay, so the equation is something like ln UP is equals to beta naught plus beta 1 times ln GDP. So this is what you have. And you are, whatever you will get from this side, it is not going to be the UP. It is going to be the log of UP. So that is why you need to be a little cautious here. Now, how do we get these two things, beta naught and beta 1? Because GDP they have given 15. So it is going to be, log of 50. But how do I get beta naught and beta 1? So if you look at the table here, you see this output seems to be from R software. I don't know if it is something else, but it looks like from R programming language. So you see this thing, ln GDP, the coefficient is 10.43. That means this is for beta 1. I specifically reminded you all, do not mug up the position, right? So this underscore constant is going to be the intercept part, right? So this is beta naught. and this is beta 1. So many people did this mistake when this question was asked. They always remember the first term is intercept, the second term is slope. So they did this blunder. So always read the question. Maybe it is not Excel output, it is something else, another software. It gives you alphabetically something else. So you never know. Or this information can be coming in passage as well. So you should know these things. So what was my beta naught? If I look at my table, beta naught was minus 24.42. So I will write minus 24.42. This is my beta naught. Then beta 1 is 10.43. So I have plus 10.43. Okay. This is my beta 1. This into log of 50. Okay. This is going to give me my ln of UP. So I'll come here. I'll use calculator. Remember, you will also have access to calculator in your exam. So use that as well. So this is what we have. We need ln. So where is ln? Natural log of 50. We need natural log of 15. So natural log of 15 is going to be 2.70. So we will have this thing as 2.70 into 10.43. You can add more decimal places. That's not a problem. So this is what we get. And then this thing minus ka 24.42. So this gives me ln of urban population should be 3.82. Okay. This is what I get. I was being asked, what is, you see, the question was, if the GDP is this, then what is the predicted UP? They were not asking me ln of UP. So I need to do this thing, change this from ln UP to UP. So that becomes UP, or you can say urban population is equals to e to the power 3.82. So let's do this thing. We have e to the power 3.82. Okay, that means we have 45.60, and this is what your answer should be. This is, by the way, in crores, so you don't need to add this thing. Okay, you don't need to add zeros here. If you see this thing, it is asking already, then what is the predicted urban population in crores of people? So in crores of people, it is going to be 45.60. From this question, I hope you got the understanding how we use the ANOVA table, or you can say the, here we were not using ANOVA table, we were using the coefficient table. But it's very important to know how we use this thing and how we do these things. Oftentimes, it's not always going to be the direct access. Like here, they applied log-log transformation. So there are multiple ways transformations can be applied. You can also square a variable. So please be cautious of these things. Read the question carefully and always don't be fixated. The first thing is going to be the intercept. So remember, read the thing and they are quite obvious. When I'm writing ln GDP, that means it is the coefficients corresponding to that thing. When I write underscore constant, that means it is the constant part. And what is constant in our linear regression equation? That is our beta naught, right? Beta naught is constant. So all other things are associated with x1, x2, but beta naught is the only thing which is constant. Therefore, this is what we have here. Now let's see the second question. So these kind of questions are very common and you will see these kind of things. They will blur out a lot of stuff and they will ask you a lot of things. So let's just read this thing. Milo Bakery is famous for three products: BA, biscuits, TA controversy cake, and hot argument drink. Dr. Milo is the owner of shop and an aspiring data analyst. He collected 5 days of data. On each day, he captures number of each product made to in total kilograms of gas consumed, so on and so forth. Using all the collected data, he has built linear regression model in Excel. Partial regression output is provided in figure 2. Using this information, answer the following sub question. Okay, so the first question was, how many number of observations are available in this data set? Okay, so how do I find this thing? How many number of observation? Do I see it here? No. Do I see total degree of freedom? No. So do you think, how do we do that? So for that, you need to read the question. He has collected data for 5 days of data. Okay, he has collected 5 days of data. That means he has 5 sample points. So number of observation is going to be 5. Now the second question, or you can say upcoming 5 sub questions were, you were supposed to find out q1, q2, q3, q4, and this q5. Okay, so let's see how we can do this thing. Let me use eraser. So from here, we have already figured out that number of observation was 5. Okay, this is done. Now what we need to figure out what is Q1. So we know if total observation is 5, number of total degree of freedom is going to be 5 minus 1, which becomes 4, right? And then this thing, how many input variables do we have? Input variables are 3. Number of business analytics biscuit, TA controversy cake, and hot argument drink. So these are our 3 variables. These 3 which you are seeing, these 3 are our input variables, or you can say explanatory variables. So you have 3 here. And we know this is 4, this is 3, or you can say this is our k, right? So this is supposed to be n minus k minus 1. That means q1 is equals to 5, which is n, k is my 3 minus 1. So that leaves 5 minus 3 is 2, 2 minus 1 is 1. So q1 is going to be 1, okay? We are done with q1. So we can probably write q1 equals to 1. Now they have asked us these things, sum square, q3, for all these things. So how can we get this thing from here, right? So for this, you need to refer to this part, which is your adjusted R square, standard error, and we know standard error is basically under root of this thing. So maybe for Q2 we can put a pause, but we know Q3 is what? Mean square residual, right? Mean square residual. And what is mean square residual? This is going to be square of standard error, right? So I have 3.36. So this is going to be 3.36 whole square. And I will calculate that 3.36 whole square. That is coming out to be 11.286. So Q3 is going to be 11.86. Was I right? 11.86? 11.2896. 11.2896. This is what your Q3 looks like. Okay. So we also know Q3. We are done with Q1. We are done with Q3. Now we need Q2 and Q4. So how can we get these things? Q2 and Q4. So if you remember, adjusted R square is given to us. And from adjusted R square, we can find out these things. What was adjusted R square? Adjusted R square is 1 minus this entire fraction, 1 minus R square. Then we had n minus k minus 1 upon n minus 1, right? This was our formula for adjusted R square. So how do we find this thing? I think I did a mistake. It is supposed to be n minus 1 in the numerator. K comes in the denominator, sorry. So this is what we have. And with this, you can find R square, right? We know adjusted R square is this, 0.97. So actually, I will write this thing here. 0.97 is equals to 1 minus this again, 1 minus R square. Then what is n minus 1? N minus 1 is going to be 5 minus 1, which is 4. N minus k minus 1 is going to be 5 minus 3 minus 1, which is again 1. So we have this thing. Now we know 0.97 equals to 1 minus, again, it would be 4 times 1 minus R square. So from here, we can calculate R square. So we have 4 times 1 minus R square equal to 0.03. So I'll just do this thing here. We have 1 minus 0.97. You have this thing. This thing would be divided by 4, divided by 4. We have this thing. So we have 1 minus R square is equals to 0.0075. Now I will take R square here and this thing here. So we have this thing minus 1. I'll multiply by minus 1 so that it becomes back positive. So this is what we have. So we know R square is 0.9925. This is what you have. And what is R square? R square is basically sum square regression upon sum square total, right? So you have some relationship here in between your sum square regression and sum square total. So at least we have one relationship to work with, okay? We know what Q2 is to Q4 would look like. And then what else we can use? We also know Q3 is this. So, okay, from here, we also know sum square residual. So this was regression. So let me use this thing. We know R square is 0.9925. What is R square? 1 minus sum square of residual, which we know. This is basically your Q3. This is what we know. And sum square total. So from this, we can actually use sum square total, right? So this becomes sum square residual is equals to 1 minus 0.9925, right, into sum square this by sum square total. This is what we have. So this would become, again, let me use calculator, 1 minus 0.9925. This is what we have. So this becomes 0.0075. We know sum square residual, we don't know sum square total. So what is sum square total? Sum square total is equals to sum square residual divided by 0.0075. What is sum square residual? We have already calculated that here. That is going to be 11.2896 divided by 0.0075. I think it was that only, 0.0075, yes, equal to this thing. So my sum square total would be 1505.28. So this is how I get access to my sum square total. So sum square total was Q4. So this part which you are seeing here, this is my Q4. Okay. Q4 is this thing. Now we already know Q4. So you also have access to Q3, right? Q2 is going to be what? Because we know this relationship, Q2 plus Q3 should be equal to Q4. Basically, sum square regression plus sum square residual equals to sum square total. We know Q4, we know Q3, so we can calculate Q2 from here. So that is going to be Q4 minus Q3. You can plug in the values and you'll get the answer. Now they're asking the F statistic. For that, you can directly even calculate mean square statistic. So this will be Q2 by 3. This will be Q3 by 1, right? Q3 by 1, and this would be Q2 by 1. Sorry, this is 3. So let me write it more clearly. Q2 by 3, this would be Q3 by 1, right? You calculate these things, you can divide them, and you will get this thing. So I'll also write for Q5. Q5 equals to Q3, sorry, not Q3, it was Q2. Q2 by 3, this thing whole divided by Q3 by 1, right? You get my mean square things, and then F statistic is mean square regression, which would be this thing, Q2 by Q3, divided by mean square residual. Residual would be Q3 by 1. So these two things you divide, you will get this thing. So you can do the calculation yourself, and this is how you will get access to this thing. So you saw this thing, you are not having access to Q2, Q3, Q4, but still somehow we did some analysis here and there, and then we came to know, yes, we can do this thing. So the idea was Q3 is under root, sorry, standard error is under root of Q3. So from here you get access to Q3. Now we have access to adjusted R square. So adjusted R square can give us, represented either as sum square residual by, sorry, sum square regression by sum square total, or it can be done 1 minus sum square residual by sum square total. So using that formula, because we were knowing sum square residual, so we went with 1 minus SS residual by SS total, and then we got access to sum square total. And when we got sum square total, then we can get access to sum square regression, and that's how we proceed. So this is how you get access to Q1 to Q5. You can calculate other things yourself. And then coming to third question. At 15% significance level, that means alpha is equals to 0.15, right? 15% significance level. Dr. Milo thinks gas consumption at his company is affected by a number of BA, TA controversy cake, hot AD, it was some drink that made in a day. Then what do you conclude about Dr. Milo? Dr. Milo is dumb, does not know statistics. Dr. Milo is genius, he is right. Cannot comment on Dr. Milo conclusion. So if you look here at this point, right, these are the individual p-values. You see intercept, this is my p-value for intercept. Alpha was this. So is my, you know, if P is less than alpha, we reject H naught. So is my P less than alpha? No, here it is not less than alpha. So we cannot reject H naught. So, you know, cannot reject H naught. Here also cannot reject H naught, cannot reject H naught, cannot reject H naught. And what was our H naught? H naught was, are these variables statistically significant or not? So you can go back here and see this thing, right? We were checking this thing. Is this p value less than our alpha? And when it was less than alpha, then only it was statistically significant. But because we don't have p value less than alpha, that means all these variables which you are seeing here, intercept and these cakes and all that stuff, these all are not statistically significant. So all these are not statistically significant. So that is important thing. And because all of them are not statistically significant, therefore it is going to be Dr. Milo is dumb and does not know the statistics. Okay, so this was the correct answer. Now coming to this question, in multiple linear regression, the R represent correlation between dependent and independent variables. So first of all, how do you calculate one correlation, right? I mean, if I have, let's say, 5 independent variables, let's say x1, x2, x3, not the dependent, I'm saying independent, x1, x2, x3, so on, so forth, x5, and this is only y. So how do you calculate in between them? So, I mean, it's first of all not possible. Like you calculate correlation coefficient between two things. So it has to be pairwise, like y and x1, y and x2, but that is not going to be R. So therefore, this is also wrong. Correlation between actual and predicted values of the dependent variable. So this is actually the correct thing. Multiple linear regression, if you read these statements which I told in ANOVA table video, that it is going to be the correlation between the actual, which is our y, and predicted, which is y hat. So this is the correct answer, that it is correlation between this thing. Correlation between predicted value of dependent and actual value of independent. No. Actual value of independent, not at all. Correlation between the errors, no. Correlation between actual and predicted value of any given independent, again, no. It was only for y, right? So we were calculating correlation between y, comma, y predicted. Okay. Correlation between actual value of dependent variable and predicted value of errors, again, no. And none of the above is obviously wrong because we have this one correct. Then similarly, we have this question again. A1 to A4, we were supposed to find out this thing. What are A1, A3, A4? These three things. Then which variables are not significant? So you can see the drill here. Here we don't have p-value. So this becomes a little more interesting. And then the last question was, how many columns are present in the data set? So here I will not do actual calculation, but I will give you the way to find this thing. What would be total number of observation? A1 is that, right? If you see this thing, A1 is for observation. So how do I get this thing? I can see total is 40. So I know total degree of freedom is n minus 1, which is equals to 40. That implies n should be 15. So A1 is equals to 15. Okay, this is easy. Now what is A3? That is also very easy, right? I have 12 residual degree freedom, 14 is total. So regression would be 14 minus 12. That means A3 is equals to 2. Okay. Now what is A4? So you already have access to this thing, A3, and you have access to some square regression. I have access to degree of freedom for residual, but what I don't have is sum square residual. So do you remember, is there any relationship to calculate the sum square residual, right? Because we don't have sum square total, so we cannot just subtract the sum square total minus sum square regression. But we have access to some standard error, right? We see this thing here, 1.92 into 10 to the power minus 15. So it's very, very small. Okay. You can see this thing. The standard error which you have here is very, very small. R square is very close to 0. So therefore, standard error is going to be this thing, 1.9240 into, I'm just doing for sake of clarity, into 10 to the power, what do we have is minus 50. So I will write minus 50. You see this thing? It is closer to 0. Then this whole thing, okay, to the power 2. This gives me 0. So that means my sum square residual is going to be 0. And when I have sum square residual as 0, therefore my mean square residual will also be 0. And okay, we don't have f statistics, so we can just clearly divide these two things. I don't know why I went that route. So we just want to find mean square regression, that is going to be 905.7333 divided by A3, and A3 was 2, right? You can see this thing from here as well, by the way, x variable 1, x variable 2. So you have two variables, that is why it will be 2 divided by 2. I have A4 equals to 452.8666. Okay. So this is how we get access to A1, A3, A4. Now it was asking which variable are significant. So you might be thinking we can go back and look at the p-values, but there is a surprise for you. There is no p-value. So how do we calculate this thing? So if you remember this thing clearly, I told this thing that every time you see that, we have 0 in the lower 95 to upper 95, this range, this is our confidence interval. So if we have 0 here, then we can, basically we cannot reject the null hypothesis, and null hypothesis was that only that these are not significant. So if we have 0, then we cannot reject that. But here if you see for variable 1, we have 2 and 2. That means variable 1 does not contain 0, therefore it is significant. Similarly, this is also significant. So both these variables are significant. So I will say both. Okay. How many columns are present in the data set? Now this is very important. You see how many columns. It is not asking you how many columns for X. It is asking you how many columns. So if you want to create this kind of ANOVA table output, you should have this kind of table, X1, X2 and Y values. You see, and then this should be how many? 15 observations. So you should have 3 columns and 15 rows, excluding this header. Okay, so 15 rows here. So therefore, how many columns? It would be 3. If they asked you how many independent variables were there, then it would be 2. But they are asking columns. Columns are all the things, x1, x2 as well as the y. So you should have this much data set to make this uh, output for data analysis to pack. Okay, so that is one thing. Now coming to this question. A multiple linear regression model as specified below is fit on dataset with 50 data points. So you have n equals to 50. MLR model is y equals to 4.1 minus this. So from here you can say k is equals to 3, 1, 2 and 3. So I have 3 input variables or 3 explanatory variables. How many degrees of freedom are present in the residual in the ANOVA table? What was degree of freedom for residual? It was n minus k minus 1. So n is 50, k is 3, so it becomes 47, and then minus 1, you have 46. So this is going to be 46. How many degree of freedom is present in the regression of the ANOVA table? For regression, it would be obviously just number of input variables, k. How many total degree of freedom are present? Total degree of freedom is this minus 1. So I will have 49. So quite easy, right? If SSE and SST for the model are 900 and 1400 respectively, then what is the model's F statistic? It is asking F statistic. Remember this thing. So I will write D part here. F statistic was sum square regression divided by degree of freedom for regression. Similarly, sum square residual divided by degree of freedom for residual. So this is REG. Probably I should write it more. Sum square regression. This is also regression. So sum square regression they have given. They have not given. It is 900 is SSE, which is your sum square error. So we will have, sum square regression is equals to 1400 minus 900. So this would become 500 divided by regression had 3 degree of freedom. Similarly, this becomes sum square residual. So sum square residual is this thing, 900 by residual was 46. Okay, so I will calculate this thing. 500 divided by 3, this whole divided by 900 divided by 46. Is it right? 46? Yes, 46. So this is what you have, 8.5185. Okay, this is what my F statistic would look like. Okay, 8.5185. Then we have another thing. The question says SSE and SST are this 900 and that same thing. Then what is the adjusted R square value for the model? So how do we calculate R square? First of all, for adjusted R square, we need R square, right? Let me write adjusted R square formula. This is what we have. Adjusted R square is 1 whole minus 1 minus R square n minus 1 n minus k minus 1. Always remember k will come in the bottom. So this is what we have. And I need R square. How do I get R square? So R square is 1 minus SS error, or you can say residual, so some square error divided by some square total. So this becomes 1 minus, I have 900 here, by 1400. So this becomes 9 divided by 14. This is what I have, 9 divided by 14. And this should be removed from 1. So I will have positive 0.3571. Okay, this is what we will have for some square, sorry, R square, or you can do it directly as well. We got 500 for R square, sorry, 500 for some square regression and 1400 for some square residual. So this is what we get, 0.3571. So this is our R square. And now we need adjusted R square. So you just need to plug in the values. It would become 1 minus, again this thing. So it would become 1 minus 0.3571. N minus 1 would be, it was 50. So n minus 1 is 49. N minus k minus 1 would be 46. So you just need to solve this equation. And I think if we solve this equation, we would get something around 0.35 only, but it would be, 0.3. Let's just do this. So we have 1 minus 0.3571. This is what we have. This into 49, into 49, oops, into 49 divided by 46. This is what we have, 0.6. And then this would be subtracted from 1. So you will have positive 0.3151. Okay. So this is our R square. And this is adjusted R square. Okay. So this is how we get access to adjusted R square. So this is our answer, 0.3151. But read the question. They said note answer, enter answer in percentage. That means you need to convert this thing into percentage. So you cannot write 0.3151. It needs to be converted into percentage. That becomes 31.51 percentage. You will not write 50% symbol, but this is the answer that you need to enter. This is a decimal. They asked you specifically for a percentage. Okay. So this is the next question. Question number 7. Multiple linear regression model as specified below is fit on data set with 250 data points. Okay, 250 data points. Then the answer the following questions, and this is the model. Y is equals to 2.1 something something. So you can see we have 3 independent variables and one we are trying to predict, and we have 250 data points. Okay, so how many degrees of freedom is present for the residuals in the ANOVA table? What is that degree of freedom for residual? It is n minus k minus 1. N is 250, k is 3. We can directly calculate 250 minus 3 minus 1. Okay, so 250 minus 3 variables minus 1. So we have 246. Okay, so for A, it is n minus k minus 1, which is 250 minus 3 minus 1, which is 246. Similarly, how many total degree of freedom are present in the fitted model of the ANOVA table? Total degree of freedom is n minus 1, which is again 249. C. If no feature engineering was performed, how many features were present in the dataset? Now, they are not asking how many columns, they are asking how many features. Features are these things only, x1, x2, x3. So it is going to be 3, right? And it was pretty simple. If they asked how many columns are present in the data set, that is going to be 4. Why? Because you will have x1, x2, x3, and y. These 3 are known as features. So that is why we had 3 here. But if they asked how many columns in the data set, that is going to be 4. So these are the answers: 246, 249, and 3. Okay. Now this is the 8th question. You are solving a regression problem with 8 explanatory variables. The data has 150 observation. Okay, so we have 150 observation. R square value is found to be 0.75. You are adding one more explanatory variable to the data set. Okay, so we had 150 data points and the R square was 0.75. Then we added one more variable. Now we have total of 9 explanatory variable. New R square value is 0.8. New adjusted square is 0.92. What does this imply? So everyone would be thinking, right, we have two models, right? This is the model old and this is model new. Okay, how do we compare? So if we had access to both adjusted R square, then we could have done. So you see this thing, they are saying solving a regression problem with 8 explanatory variable. This was the data 150 and this was the R square for the older model 0.75, right? So if I could calculate, because I know adjusted R square is 0.92 here, if I could calculate old adjusted, let me write it clearly. If I could calculate old adjusted R square and compare with the new adjusted R square, then we can comment, right? How do I comment? If old adjusted R square is less than new adjusted R square, that means variable added are significant, right? So this is how we compare. But there is a catch in question, and which is very important. If you look at the options, they have given you a lot of things, and even if you read the question, it kind of triggers some warning. They are saying new R square is 0.8 and the new adjusted R square is 0.92. Oftentimes, if you see the formula, uh, it's adjusted R square and R square, they are supposed to be very close to each other, right? So if you see this thing, you have R square as this thing and adjusted R to be that thing. Adjusted R square is always going to be lesser than the original R square, right? If you see the formula, it's quite obvious. So this is the formula. If I show you, adjusted R square is 1 minus R square n minus 1 upon n minus k minus 1, right? Now, if you see this thing, if n is much, much, much higher than k, right? Let's say we had 1 lakh rows and only 2 columns. So k is equals to 2 and this is 1 lakh. So this fraction is practically tending to 1, right? This tends to 1. I mean, you can ignore the k because k is much, much smaller with respect to n. So both these things become n minus 1, n minus 1. So they kind of tend to 1, and therefore adjusted R square at max can be equal to this thing. Adjusted R square at max would be 1 minus 1 plus R square. So 1 gets cancelled. So at max, adjusted R square would be equal to R square, and that too is, in the limiting sense, because we are assuming n is much, much, much higher than k, right? This fraction n minus 1 divided by n minus k minus 1, this whole thing would tend to 1. It will never become 1, right? It will tend to 1. So that is why at max, adjusted R square can be equal to R square. But if you see here, we have R square as 0.8, but adjusted R square is greater than that. So do you think it is possible? No. So that is why, and you can check this thing manually. Put this thing there. We have R square as 0.8. You have n equals to, I think, 150 or 250, 150, and k equals to 9, because this is for the new model. So you can plug in this thing and you will observe that adjusted R square would be something else. So therefore this question information is itself wrong. You see this thing, new variable does not improve model, new variable alone has high explanatory power, data is too small for fitting model. So this is totally rubbish, none of the above. So this is going to be the correct answer, none of above. Why? Because the adjusted R square which they have given in the question, it's actually wrong. So every time, they give you this kind of question, you have access to R square and you also have access to adjusted R square. Please, please, please cross check. If R square and adjusted R square are given, cross check, right? If in this case, let's say they only told, you added one variable and just skipped this information that R square was 0.8, they only told adjusted R square is 0.92, then what do we do? So in that case, you will calculate the old model adjusted R square. Basically, R square was 0.75, K was 8. You calculate that adjusted R square and then you can directly compare. If new model's adjusted R square is higher, that means variable improved the model. If older R square was higher, that means variable is not improving the model. So if you have both R square and adjusted R square, you need to cross check. If you only have either, let's say R square or adjusted R square, then you can assume given information is question is true and we can move forward. So always cross check this thing that do we have something wrong in the question, because this question was very cleverly made. So this is the correct option which you will have, that none of the above, because the adjusted R square value which they have given, it is wrong. It cannot happen. So now coming to this question, what does the term multi-collinearity refer to? Select all that applicable. Dependent and independent variables are not related, not at all. Dependent and variables are linearly dependent. Dependent variable is linearly related to another dependent variable. So again, we are, talking for this thing. It is going to be D, none of above. Why? Multi-collinearity is for only independent variable. And if you see the options, they were between dependent and independent. So we don't want this to be between dependent variables. Multi-collinearity is for the independent variable. That means we don't want any high correlation between xi and xj. So we don't want this thing. This should not be high. That is what we don't want. So that is why none of the above is correct. And these are our independent variable. Okay. Oh, so now coming to very famous question. Search Milo motor on discourse. I have explained this thing there as well. So I would also encourage you to search this on discourse. Milo motor question. These are the 10 model outputs which were given. So now let's read the actual question. This is the actual question, by the way. Quite a big one. Milo's Motor is a motorcycle brand that manufactures electric two-wheelers. Wants to understand the relationship between mileage, storage, charging time in minutes on sales volume, right? So that means these things which you are seeing here, these are my input variables, or you can say explanatory variable, x1, x2, and x3. These three things are that. Sales volume is what I'm trying to predict. This is my y. The owner of company, Dr. Milo, has only half-baked knowledge of regression. Hence, he created several model 1 to model 10, which are given below on appropriate data available. These are the questions. So these are the models which you can see. Model 10, and I'm going above. So these are the models which you can see. Model 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10. Now it is asking, how many observations are present in the data set used to build model 1? So let's go to model 1. What do we have in model 1? Model 1 is this thing. You see this thing? They are asking how many observation. How do I get number of observation? Number of observation is n. And if you see here, this is what? This is k. This is n minus k minus 1. So you can do it from here also. 17 is equals to n, k is 1, n minus 1 minus 1. So therefore, n should be 19. Okay. Another way was, these two, if you add up, it should become 18. And this 18 is n minus 1. So therefore, n should be 19. So we know this thing, n should be 19. Okay. So I'll go back here. I will write A is 19. So A is 19. Basically, n minus k minus 1 should be equal to 17, and k was given to be 1. So this is what you have. Then it is asking, what is the total indirect effect of mileage on sales volume? So now if you remember this word indirect effect, direct effect and all that stuff, we used to study this thing in the path diagrams, right? So I think we need to make a path diagram. How do I write that thing? So we had three variables, right? We had, this is asking for mileage, right? So mileage is basically x1. So I will just write x1 for the simple terms. So mileage, or maybe we can use that. No problem. X1 is mileage, x2 is something else, and x3 is your charging time. Mileage, what was that? Mileage, storage space, and charging time. So this is what you had, these three things. And we use these three things to predict y. So there is some direct effect and there is also some indirect effect. How is indirect? If I change x1, that means if I change mileage, is there any change in the storage? Is there any change in the charging time? So this is what we need to see, right? And they're asking the total indirect effect, right? So if you remember, indirect effect for this would be, let's say I'm labeling this. So this is A, this is B, this is C, and this is D, this is E. So total effect is equals to direct effect plus indirect effect, right? They are only asked indirect effect. So direct effect is actually A, this thing, x1 directly affecting A. This is your direct effect. So this path which you are seeing, this is your direct effect. X1 is directly affecting Y by changing, right? So this is the direct effect, and direct effect is already A. Indirect effect would be x1 changes x2 and x2 in turn changes y, right? So that would be this thing. Indirect effect would be d into b plus e into c. So this part which you are seeing is going to be total indirect effect. But how do we get answer to d, b and ec? What are these values? So for this, you need to go here in the models and you actually need to find which model is going to give you that. That is going to be a little big exercise for you all. So, let's just see this thing, how we can do. So we know this thing that this part which you are seeing here, this is what? If I will write this thing in words, how is my x1 changing x2, right? So D is how x1 changes x2. So that means x1 would be on input side, x2 would be on output side. So I need to find a linear model where x1 is the input variable and x2 is the output variable, right? So let me find that thing. If any output we can see, x1 is the input variable. That means these things which you are seeing, intercept and mileage, this is the input variable, right? If you remember, this is the coefficient part. So this is basically telling you this is my intercept and this is the variable. That means this is for charging time and mileage. So just to give you an example, it would be something like charging time is equals to 308 0.012 minus 2.3 times mileage. So you see this thing, this mileage is your input variable or explanatory variable, and charging time is the variable you are trying to explain. So similarly, we need to find something where this second thing which you are seeing, the input variable would be what? It is going to be mileage, right? So we need to find something where input is mileage and x2 is going to be that. So if we come here, input is mileage and x2 is storage space. So yes, this model is correct. Now, how do we see this thing? How is it changing? So from here, you can see that if this is going to be my equation, right? First of all, so I am replacing this by x1 and this by x2. So this is what we have. x2 is equals to minus ka 34.38 plus 0.9388 x1. And if you remember, what was this coefficient? How we used to interpret betas? Betas were what? If I change 1 unit of x1, beta units will change in x2, right? This is all the definition. So if I change x1 by 1 unit, x2 is supposed to update it by 0.9388. So similarly, you see this d value which you are seeing here, this d is coming from model 4. Model number 6. Model 6, and this is going to be 0.98. I think that was that. 0.98. 9388. So this value is going to be my D, 0.9388. So I'll write it here, 0.9388. Then we have B. B is what? X2 changes Y. That means my storage, I think storage was that, X2, yes. So storage, how storage changes Y. So I need to find something where storage is input and Y is sales. So I can see it here as well, right? Storage is input, right? This is my input and this is my output. So X2 and Y. So this model gives you this thing. Similarly, you will write out the entire equation and you will see that if I change 1 unit of storage space, this much change is supposed to happen in my sales, which is my Y. So this is going to be my B. So B comes from model 8 and this is going to be what? Minus something. I think it was minus 17.47. So this is going to be minus 17.47. Similarly, you can find for E and C. I will directly write it down. E comes from this one and C comes from this one. So E would come from your model number 4 and C would come from model number 8. Sorry, no, it would come from model number 10. This is also supposed to come from model number 10. Yes, because we are, observing two things. Why this is coming from model number 10? Let me explain that. This was B coming from model 10, not model 8. Because if we go here in this model, model number 8, this model is built assuming, assuming other variables, that is x1 and x3, are not changing, right? This is what we have. But actually, if you see my mileage, which is x1, that was changing. So this was built assuming it was not changing. So therefore, you cannot take from here. Actually, you would suppose to take it from here. Here, all the three things can change. Mileage, which is your x1, storage, which is x2 and x3. So you need to take the coefficient from here, right? So how my y changes with respect to this thing? So this is the equation you have. Y is equals to, that is your sales, is equals to intercept, that is minus 222.56 plus 26 into mileage plus 8.9 into storage plus 19.4 into charging time. So this B is actually coming from model 10 and that is going to be 8.9. How storage changes that thing. So 8.9 here. Similarly, E would come from something else and C would again come from model 10. Because for C, both things are changing, x1 and x3. So for this, you see how x3 affects y. So how x3 affects y is going to be this thing, 19.40. So C is going to be 19 point, what is that? 19.40. 19.40. And E is coming from model number 4, and this is equal to, I think, minus 2.3. Minus 2.3. Okay, so if you go back to model 4, this is your model number 4 here, and in model number 4 you can see how mileage is changing your charging time. So this is my x3, this is my x1. So this is the individual effect of mileage on charging time, and then we need to get this thing from here. How mileage is also changing and charging time also changing makes this thing. So 19 point this thing. If you will solve this equation, it will give you this thing. I think 0.9388 into 8.9 plus minus 2.3 into 19.4. So I'll solve this thing. It will give me 0.9388 into 8.9 plus we'll have minus 2.3 into 19.4. So this is what you will end up having. It should be minus 36.264688. This is the final answer. So this is the total indirect effect of your mileage. That means if I change mileage by 1 unit, this is the change happening in my sales indirectly, right? So direct effect is something else. This is the indirect effect, basically this part. this to this, and this to this. So this is your indirect effect. And please remember, first part comes from the individual models, how x1 changes x2. But how these things also change each other. So these parts A, B, C come from model 10, because the issue in these models was that they assume other things are constant, but in actual, mileage is changing storage, mileage is also changing charging time. So therefore we need to take this bigger model. So that is how you get this thing. Now the next question is, what is value of t statistic associated with the intercept in model 3? T statistic in model 3. So we go here, model 3, what do we have in model 3? This is what we have in model 3. If you remember formula for t statistic was what? Beta by standard error. Beta, I think it was for intercept or charging time. It was for t statistic associated with intercept current. So here we need for intercept, that means it is going to be 65.813 divided by 7.033. So this is what your answer is going to be. You can calculate it using the calculator. So let me find this thing. It is going to be 65.813 divided by 7.033. This is going to be 9.357. So this is my C option. Okay. Now the next question was, what is the adjusted R square? So let me see it here. The next question is, C is 9 point, I think, what, 9.35. So this is 9.35. D is what is adjusted R square value for model 10. So let's see model 10. What do we have? Adjusted R square. So for this, if you see here, you have mean square here, right? Degree of freedom would be what? For regression, it would be 3, because you have 3 input variables, right? So that would be, it would be 3. What would be residual? So 18 minus 3, this would be 50, right? How do we find adjusted R square? So if you rearrange stuff a little bit, right? Adjusted R square is what? 1 minus R square. If you remember, R square was 1 minus SS residual by SS total. So 1 minus R square is basically this thing, sum square residual by sum square total. Okay, so I'm just rearranging the formula of R square. What did we had for adjusted R square? We had this whole thing, 1 minus R square, right? And this was n minus 1, this was n minus k minus 1, right? How do I rearrange? This thing would become that fraction. So I would write this becoming adjusted R square is equals to 1 minus, this thing becomes sum square error divided by sum square total. This thing was, in denominator. So you have this into n minus 1 and this divided by n minus k minus 1. If you see this thing, if I rearrange this again, this would become 1 minus sum square error by this thing would become your mean square error, This would become, divided by mean square this thing, sum square total by that, sum square total by n minus 1. So you can do it from here as well. And let me see this. So this is what you will have. And yeah, so let's just jump into it. We have access to, what do I say? This thing. And because we know what is our sum square, this one, regression, and we also know what is sum square error, we can get access to sum square total. So, let's just remove this thing here and do this calculation clearly. If I have space, okay, I think I need to add space, just a second. So this is what we have. It is our part number D, part D. Okay, adjusted R square is what? 1 minus R square n minus 1 n minus k minus 1, right? If I get access to R square, we can get that. What is R square? R square is SS regression by SS total. Do we know sum square regression? Is that given in model number 10? So I go back to model number 10, sum square regression. Yes, sum square regression is given, this thing. So I have that thing. But do I have access to sum square total? No. But can I calculate that? Yes. Sum square total is equals to sum square regression plus sum square error. So do we have access to sum square error? No, but we have access to mean square error. So can we get that? Sum square error? Yes. We know that mean square comes by dividing sum square by this degree of freedom. So we can simply multiply these things to get that. 9728.032 into 15. This is what my sum square error would look like. This is what my sum square error is. If I add this thing into sum square regression, it would become sum square total. So 1026630.47, this thing is supposed to be my sum square total. So I know sum square total is equals to 1172,550.95. So this is what your sum square total is. You also have sum square regression. You can easily calculate your R square. What is going to be that? 102,666.30.47 divided by 1172.550.95. So you see, I think I did something wrong here. 102, like, yeah, you can check this thing. This was 102, that thing. And that part was coming out to be, let me do it again, 9728.032 into 15, right? This is what we have here. 18, three things come up here, 15, correct. So this is what you should get, right? 145,902 plus this thing plus above would give me that 102, 111, 102, 666, 666, 30.47. So you get, okay, this is the wrong answer thing I've written here. This is not supposed to be that. So sum square total would be this value, 104,12550.95. Now you can calculate your R square. That would be 102,666.30.47 divided by this value, 104,12550.95. You see, this is what we get as R square, 0.9859. So R square is 0.9859. You can just plug in this value in this formula and you will get access to it. What I did was I broke down sum square total into, sum square regression plus sum square error. So this is what I broke down, and that's what how we can do it. So we have done A, B, C, D. Now they have asked for F statistic. So we have access to A, B, C, D. E is going to be F statistic. We know F statistic is mean square by that thing. So again here we have access to this thing here already. We were asked this part. So we can directly find things from the calculator. We have 102,666.30.47 divided by 3. This is this part. So I will write it here. That is going to be 3422.10.15. So this is what you have. This thing is supposed to be divided by 9728.032. And this is supposed to be 351. This part is supposed to be 351. So this part which you are seeing, this is supposed to be 351.788. Okay. So this is how we get access to our adjusted, F statistic. Adjusted R square was in the previous part. So that is coming out to be 351.788. Quite easy. You have already access to other things. So it is 351.788. Okay. So the next question was, for which of the following tabulated F values will the null hypothesis not be rejected for model 10? So when do we not reject the null hypothesis? For null hypothesis to not be rejected, tabulated should be greater than computed, right? Tabulated should be greater than computed, or you can say calculated. So we already have calculated value, which is 351 point something. So if it is greater than, if the tabulated value is greater than this part, right, then we can not reject the null hypothesis. So therefore, if we see only option these two are satisfying the condition. So therefore, these two, C and D, are correct option. Why? Because tabulated value should be greater than computed. Computed, we already know 351. So everything greater than this will result in not reject the null hypothesis.